All right, so this is a video on the cosine ratio for right triangles, setting up the cosine ratio. So I did a video for sine, and I'm going to do a video for tangent. All right, we're taking this in baby steps because we can't actually be together because of the, this whole quarantine thing. So in this video, I'm going to talk about how you find now the cosine relationship. If you are unsure about how to find sine, then you want to watch that video. Like I said, if you're unsure how to find tangent, you want to watch that video. If you need specific one-on-one help or you have questions, make sure you come to my office hours. I have office hours Monday, Wednesday, and Friday. All right, they are posted on my classroom. All right, and it shows how to get into them. So make sure you take some time for that. All right, so the cosine ratio for right triangles is spelled cosine, like that. We write it as COS. All right, and it's a set relationship. So before I said we have this SOHCAHTOA, which is the some old hippie caught another hippie tripping on acid. You don't have to memorize that because, we're not live together. We're going to use the CAH part. So the cosine relationship to find an angle measure, and I'm sorry, that was a really terrible theta. All right, that just says that the unknown angle, it's equal to the relationship between the A stands for the adjacent side over H, which is the hypotenuse side. So once again, if you've done sine, we're using the hypotenuse again, which is always the hypotenuse. Adjacent means next to, okay? Mathematically, adjacent means next to, so it's going to be an angle where this side is part of the angle, okay? So when I go to, for example, set up a problem, and I'll go back to my old reliable. I have this triangle. It's a right triangle, ABC. I could find the cosine of A or C. I don't generally need the cosine of B unless I was trying to find like a missing side because I already know that angle is 90. So very rarely do we use the angle that's actually 90. All right, so let's say I want to find the cosine of angle A. My first step is to identify the hypotenuse. Okay, always find the hypotenuse first because the hypotenuse is the hypotenuse is the hypotenuse. It will not ever become the opposite or the adjacent as long as you are doing this for A or C. And so if I find the hypotenuse, then that's one less side I have to worry about. So this right here is my hypotenuse. Remember, the hypotenuse is the longest side, or it's the side opposite the 90-degree angle. Okay, so here's the 90-degree angle. All the way across from it is the hypotenuse. So this is my hypotenuse. Now, I have to look at the angle that I want to identify. And I want to look at that angle, and what that's going to do is that's going to help me decide which side is my adjacent. Okay, so if you do these all together, then what I would normally do is I would take one color pen and I would do opposite and adjacent for that angle, and then I take a different colored pen and I do opposite and adjacent for the other angle. Here I'm going to deal with angle A. All right. The opposite side would help us if we were finding sine, and opposite is all the way across the triangle. So I know this is my opposite. Therefore, there's only one side left. And remember, I said adjacent means next to. So if this is my angle, the side that's right next to this angle, that's not the hypotenuse, is here. So this right here, come on, marker, you can do it, is my adjacent. Adjacent will be next to the angle, but it won't be the hypotenuse. So now it's adjacent over hypotenuse. My adjacent is 3. My hypotenuse is 5. So the cosine of A will be 3 over 5. That's all I'm asking for. Is I'm not asking for you to do any kind of complicated math. I don't want it as a decimal. I don't need you to find the angle measure unless that's what you want to do. All right, so now let's go ahead and let's find the cosine of angle C. Right? The hypotenuse is still the hypotenuse. So if you wanted, you could say, oh, well, I know cosine is always over hypotenuse, so I know my hypotenuse is 5. However, now we need the adjacent side to angle C. Now this is where it changes, okay? So if here's my angle, this side is all the way across, so this is now opposite of C. Notice it's the opposite for C, but the adjacent for A. All right, so if you're working in one triangle, what will happen is when you switch angles, the opposite and the adjacent relationship will also change. All right, that means what side is directly next to this angle? It's this side 4 right here. So now this is my adjacent. So my relationship of adjacent over hypotenuse is 4/5. All right, I'm going to do one more of these with you. You can see why I want you to watch the sine video first, because if you're like, wait a minute, that happened too fast. Watch sine, because I explained it there first. All right, I'm going to go ahead and erase this and draw a new right triangle, and I'm going to find cosine of 2 angles again in that triangle. Okay, if you need that, right? In class, I would normally pause and let you finish writing it, but we're not in class, so go ahead and pause me. All right, so now next triangle. These angle measures aren't necessarily going to, or the side measures aren't necessarily going to be completely Pythagorean appropriate, because I'm not worried about that relationship right now. I'm just worried about you being able to find the ratio. So if that makes you angry, then please leave me a really angry comment, because that would be lovely. So I'm just going to pick some numbers. Okay. Side measures can be really large. They don't have to be very small numbers. Usually I do smaller numbers, and usually when I'm doing this for real, I'll have them be exact and they'll actually work out okay, or they'll be like Pythagorean triples. All right, so let's go ahead and let's first find sine of angle A. And now I haven't done this yet. We're going to find sine, or I'm sorry, not sine. I missed my classroom. We're going to find cosine of angle A, and then we're going to find cosine of angle B, because I moved the letters around a little bit, and now C is my 90, so C is the angle that I'm not going to look for that relationship for. All right, so let's start with A, cosine of A. The side that's my hypotenuse is the longest side, and it's opposite the 90. If all 3 sides are given to you, then you just go to the one that's the longest and label it hypotenuse. All right, now I'm in cosine. I need my A, which is my adjacent. So looking at this angle, what side is next to the angle? 30 forms the angle, so it's next to, but it's the hypotenuse. Sorry. Ooh. And then 20 is next to A, and it's not the hypotenuse, so I know that this is my adjacent. If it helps you to identify opposite first, the one that's furthest away, sometimes that helps people if you're having trouble with adjacent, then identify opposite first, even though we're not using it right in this example. The penultimate assignment for this is going to be for you to find sine, cosine, and tangent of the same angle. So it's okay to label all of them at once. All right, now cosine is adjacent over hypotenuse. My adjacent to A is 20. My hypotenuse is 30. Now, you can leave it like that. If you are used to reducing, you could totally reduce this. Okay, it's just giving you a side relationship that would eventually tell you the angle size. Okay, all right, now let's go ahead and do B. Here's B. Notice the hypotenuse is still the hypotenuse, but now this is my opposite from B. Therefore, 24 is the one next to B. This is now my adjacent. When I go to find the cosine of B, my adjacent will be 24 over 30. That can reduce as well. You don't have to. I wouldn't come at you if it wasn't reduced at this point. Let's just get used to finding the ratios. You can divide them both by 6. And you could get that the relationship is 4/5. Okay, so for sine, you use opposite over hypotenuse. For cosine, you use adjacent over hypotenuse. And then the last one we're going to do is we're going to do tangent, which is opposite over adjacent. Okay? All right. Questions? Come to office hours.